as our first ticket item. Before I get into that though, I just want to thank you guys for a really great semester. It's been fun having you guys in our virtual classroom together, and I appreciate all of the interactions that we've had as best as we can manage having interactions in this kind of environment. And I appreciate all you guys for coming and being here on the last day so that we can close it out strong together. Okay, one quick announcement, and I'll get to some more in-depth announcements, including talking about what the final exam is going to be like. That will come after we finish up chapter 10. So hold off on any logistical or administrative questions until after we finish up chapter 10. I will give you guys plenty of time to ask me whatever you want to ask me. But I do want to note that I am going to be having office hours this week as we come down the home stretch before your final exam. The first set of those will be tomorrow afternoon from 1 to 3 p.m. I will be in person in my office, so you're welcome to stop by in person. I will also have the Zoom link on. I'm also going to have office hours on Thursday morning. This is the day before your exam. Those will be by Zoom only. And I may have some additional kind of pop-up office hours here and there throughout this week. So just keep your eye on Canvas for any announcements related to pop-up office hours. But these two are for sure and set in stone, and I will be available to you during these times coming into your exam. Okay, so to start off today, we do have a little bit of leftover chapter 10 to finish off. I promised you guys that I would do that at the first part of class today, so that's what I'm going to stick to. But don't worry, it is just 4 new slides, so it's really not that much material, and we'll cover it in short order. And then after we finish covering the rest of chapter 10, I'm going to take some time actually to go through announcements and reminders. We'll talk about the final exam format. We'll talk about grades. We'll talk about all those things. And you guys all have plenty of time to ask me questions about whatever sort of administrative or logistic things are on your mind during that couple of slides. And then I'll give you kind of a very brief topical overview of what all we've learned this semester, not going into very many details. And I'll give you some of my study tips for how I think you guys would be best served as you're approaching the final exam. And I doubt we'll have time for it, but if we have time, I'll pick some topics and just do kind of a random spot check review of certain topics. But first, let's go ahead and finish up chapter 10. So I showed you guys this slide on Friday. The first couple are just going to be a review from Friday, get everybody back on the same page. What we're talking about is the second new method or approach to synthesizing alcohols, right? So in chapter 10, we learned about organometallics as a broad category of reactions to synthesize alcohols. This is going to be the second category of reactions to synthesize alcohols that's new to chapter 10. And that is taking any carbonyl compound, so C double bond O, and reducing it using a reagent that acts as H minus, a hydride ion, which means it's a hydrogen atom with 2 electrons, so it's carrying a negative charge on it. And this hydride ion can provide the electrons to reduce a CO double bond to a CO single bond. So keep in mind, when we're reducing, we're gaining electrons. So if the carbonyl group is getting reduced, that CO double bond is gaining electrons and being reduced to a CO single bond in the form of an alkoxide ion. And so what that looks like is using one of these complex hydride reagents, either sodium borohydride or lithium aluminum hydride. And we have to choose carefully between these two. They have different functionality. And I'll talk about that over the next couple of slides. If we take one of these reagents and expose it to an aldehyde, we will get a primary alcohol. If we expose it to a ketone, we will get a secondary alcohol. In both cases, we are basically adding the equivalent of H minus across that double bond. So what does that look like? This is a slide I also showed you on Friday. We have our nucleophilic H minus, and that nucleophile attacks our carbonyl the same way we have seen all throughout, beginning with chapter 9 and acetylide chemistry, continuing on in chapter 10 with organometallic chemistry. This is nothing new. We have a nucleophile that is using its electron buildup to create a new bond with an electrophilic center. So we have a new carbon-hydrogen bond in this case. And in doing that, we have provided some electrons brought in by our hydride ion to this carbonyl group, making this a reduction of a carbonyl. So we formed this new CH bond, and in forming that new CH bond, of course, we had to move our pi electrons out to be a lone pair on the oxygen. Otherwise, we would have broken the octet rule for that electrophilic carbon. And then in a second step, we can quench our alkoxide ion by giving it a proton source, whether that is water or H3O plus or just H plus. Excuse me, the allergies are getting to me. So this is the overall overview of reduction of a carbonyl. In a two-step fashion, we can have hydride attacking the carbonyl to provide those electrons and reduce that CO double bond to a CO single bond and form the alkoxide. And then in a second step, we'll protonate that to get our final product of the alcohol. On Friday, at the very end of class, I introduced you guys to sodium borohydride. So both of the reagents that we're going to learn about for chapter 10 to do this are called complex hydrides, because our hydrides are actually bonded to another element in this kind of a complex ion fashion. And that helps to make these hydrides nucleophilic, but not basic. In the case of sodium borohydride, this is the more mild of the two reagents, and it only can reduce aldehydes and ketones. It cannot and will not react with any of the other carbonyl compounds that are available to be reacted with, right? So only aldehydes and ketones. And that means it's really useful as a selective reagent. So you can imagine if you have a compound that has a ketone or aldehyde in it, but also has, for example, a carboxylic acid or an ester, you can choose to just reduce the ketone or aldehyde with sodium borohydride, and that actually works very effectively. So I've shown you two simple examples here. These are not selective examples. These are straightforward examples. On the left, there is an aldehyde. So this aldehyde, after the hydride addition, you can see our hydrogen, new carbon-hydrogen bond, and then we've protonated on the other side. So we've added essentially H2 across that CO double bond, but not in a molecular fashion. What I just described is not the mechanism of how this happened. It is only the end result of what happened. Taking our CO double bond, and we've exchanged that to be a CO single bond, where both the carbon and the oxygen now have new sigma bonds to a hydrogen atom. That carbonyl is said to have been reduced because of the electrons that were brought into the system by the borohydride. If we were to have a ketone starting out, as you can imagine, if we add an H minus to the bottom of this carbonyl and move those electrons up, well, we had two carbon-carbon bonds already, so we still have those two carbon-carbon bonds. So if we start out this reaction with a ketone, we will get a secondary alcohol because of the two carbon-carbon bonds that the ketone already had. And notice if we had an aldehyde to begin with, we end up with a primary alcohol because we only had one carbon-carbon bond coming in on the aldehyde. The other one was a CH bond, and we're bringing in a new CH bond. Okay, so this is sodium borohydride. Like I said, it's the more mild reagent of the two, and it only reacts with aldehydes and ketones. The other reagent that we have to work with is called lithium aluminum hydride. You can write out the molecular formula, lithium AlH4, or you can also write out the acronym LAH, and you'll see both depending on the source of whatever is being presented to you. They're interchangeable, these types of shorthand notation. So this works mechanistically the same exact way that sodium borohydride does, but it is a much, much stronger reducing agent. So it does the same thing to ketones and aldehydes. Ketones will become a secondary alcohol. Aldehydes will become a primary alcohol. But in addition, lithium aluminum hydride is strong enough that it can take an ester or a carboxylic acid all the way down to the primary alcohol by adding in two equivalents of H minus, the same way that we saw with esters and other carboxylic acid derivatives. Organometallics could add in two equivalents of an R minus group. The same concepts are at play here. So what does this look like? Well, here is an ester. If we treat this ester with lithium aluminum hydride, or LAH, I've color-coded the hydride portion of this, then the first equivalent of hydride will reach into that carbonyl and add into that carbonyl. But just like in the case of organometallic reagents, this OCH3 is a reasonable leaving group. So that intermediate can collapse and make this OCH3 leave, giving us an aldehyde intermediate. And then that aldehyde intermediate is susceptible to a second attack by lithium aluminum hydride to end up giving you this primary alkyl halide. Okay, so what I want to drive home the point about here is that these two reagents are both hydride sources. They both act the same way mechanistically by delivering H- to a carbonyl and reducing that carbonyl. They're identical for aldehydes and ketones, but lithium aluminum hydride can additionally reduce any other carbonyl that comes its way, whereas sodium borohydride can only act on aldehydes and ketones. And so here is our kind of reactivity diagram, if you will. And you can see I've set these up in increasing ease of reduction, with aldehyde being the easiest to reduce all the way at the top. And you can see that sodium borohydride only applies to these top two, whereas lithium aluminum hydride reduces all four of these different functional groups. All right, so what does that mean for us as chemists? Well, as you can imagine, this turns out to be a very useful distinction, that even though these two reagents seem to be very similar, they act very similar mechanistically, we can take advantage of this different strength, this differential between these two reagents, and use this to our advantage when we're trying to design approaches to synthesizing a target compound. So I got some examples of that. Here's a compound that it's the same substrate in both cases, but it has a ketone functionality on one side of the molecule, and on the other side of the molecule, there's an ester functionality. If you were to do this reaction, this reduction of the carbonyl with sodium borohydride, you would reduce the ketone and you would leave the ester untouched. However, if you were to do the same substrate and react it with lithium aluminum hydride instead, you would reduce the ketone to an alcohol. That's a secondary alcohol because it started out as a ketone. And you would also reduce the ester to a primary alcohol. So now make sure you're keeping track of your carbons. After the ring, we've got 1, 2 carbons. This carbon that holds the carbonyl will become the carbon of our primary alcohol. So you can see that reflected in the product, 1, 2 carbons, and then that second carbon holds the alcohol. And our ester in this case became a primary alcohol. And so you can see ultimately which of these would be better. Well, it depends on what we want, right? So it depends entirely what our target is. If we wanted to reduce both, then the bottom pathway would be better. If we wanted to reduce just the ketone, then the top pathway would be better. And so it just depends on what the goal is and what you're trying to do as a synthetic chemist, what your target molecule is. But knowing the distinction between the reactivity levels of these two becomes very important when you're trying to design a strategic synthesis. All right, the last type of reaction that I want to tell you guys about is kind of a subtlety and a little bit of a random feature in chapter 10, but I just wanted to make sure to cover it. So carbonyl compounds, well, that's a CO pi bond, right? That CO pi bond, you might expect it to have some similarities to a CC pi bond, like alkenes. And you might wonder to yourself, well, why do we use these complex hydrides? Why don't we just use molecular hydrogen and a metal catalyst? And it turns out that most of the time, molecular hydrogen and metal catalysts are not strong enough to do this reduction in the same way that we saw for alkenes. However, of course, chemists are always trying to figure out the best way to do things and new reagents to get things done. So there's a very specialized metal reagent called Raney nickel. And Raney nickel is a powder that can be used in much the same way that the palladium or platinum catalysts could when we were doing hydrogenation of alkenes and alkynes. But rainy nickel is much more reactive. And so it is capable of adding molecular hydrogen across a carbonyl bond, the same exact mechanistic way that other solid catalysts do, like what we saw for alkenes. This reaction is almost never used in real life. In real life, chemists tend to use one of the complex hydrides because they are much safer, they are better controlled, and this is a very, very vigorous reaction. It turns out rainy nickel is actually also pyrophoric, which means that if it is exposed to oxygen, it will catch fire. And so you have to be careful when you're doing this reaction to not allow any oxygen into the reaction flask. Otherwise you will have fire. And fire in combination with hydrogen is a really bad combination. So overall, this reaction has a lot of safety concerns, and there's this very convenient complex hydride, either sodium borohydride or lithium aluminum hydride, that is a very convenient and safe, relatively speaking, alternative to rainy nickel. So pretty much nobody uses rainy nickel except in very unusual cases. And just for kind of comparison, if you had a compound like this substrate here that has an alkene on one side and an aldehyde on the other side, if you tried to reduce this aldehyde with rainy nickel, you would also reduce the alkene. Right, so that's the other problem with rainy nickel. It's not just a safety issue, but it's also a selectivity issue. Because if you wanted to reduce this aldehyde but leave the alkene in place, you could not use rainy nickel. But if you wanted to use sodium borohydride, you could indeed reduce only the aldehyde and not the alkene. Likewise, if you wanted to reduce the alkene and hydrogenate the alkene and leave the aldehyde in place, you could use a palladium or platinum catalyst, and you could get that selectivity, the opposite selectivity, the other way. So these are just things to think about as you guys are becoming more advanced chemists and organic chemists at that. And that's actually, I believe, my last slide for chapter 10. Yeah. So I'm going to pause here and see if anybody has any questions. I'm actually going to pause on this slide and see if anyone has any questions about complex hydride reducing agents, or if you guys have questions about the organometallic class, the organometallic reagents that we discussed on Wednesday and Friday last week, you can ask those too. Go ahead, John.
Got a question. On the example with the sodium borohydride and the lithium aluminum hydride, the ring didn't have any double bonds in it. Is there a reason? Like, would they have done anything special with the double bonds?
So if there had been a double bond in this ring, is that what you're asking about?
Yeah.
So if there had been a double bond in this ring, it would have been a carbon-carbon double bond, right? And neither of these reagents would bother it. It would just...
Okay.
So yeah, if there had been like a double bond here, for example, it would have been no problem.
Okay, cool. Thank you.
Yeah. Okay, well, if nobody else has any questions on chapter 10, we are going to move on and talk about some end of the semester stuff, starting with announcements and reminders. And so that brings me to the question in the chat box. Yes, today is the last day of class. So Wednesday is a reading day. The formal last day of classes for the semester is tomorrow. But our class doesn't meet on Tuesdays anyway, so today is our very last day of class together. And your final exam is Friday of this week. So I'm going to spend the rest of the time of class talking about some logistics and administrative things and an overview and then some study tips. And so we'll just take it one by one, but this is your chance to kind of ask all the questions that you guys have about administrative-y type things. So here we go. Announcements and reminders. First thing, just some reminders as we're closing up chapter 10. We covered our last couple of slides today. It was actually 4 new slides, not 3 new slides, so it's a typo in my slide. But we've gotten through the last slides today, so congratulations, everybody. It is now 1:22, and you guys have fully finished the 10 chapters of this class. So everyone should pause and take a deep breath and maybe a little silent cheer. You guys should feel proud of yourselves. So congratulations on making it through the end of chapter 10. You do have a couple of assignments related to chapter 10 as a reminder. These are both, there's a graded achieve homework and there's an open book, open notes quiz. Both of these are set to be due at the end of the day tomorrow, so 11:59 p.m. on Tuesday. And the reason I chose that timeline and that date is because I don't want these things hanging over anyone as we go into the reading day on Wednesday or final exam period, which starts on Thursday. That being said, if you guys are having some particular academic hardship with getting these things done by this date, you can send me an email with your reasonable request for an extension and I will consider it. But I'm keeping these due dates as posted here to encourage everybody to get through chapter 10 by the end of the day tomorrow so that you can spend Wednesday and Thursday and Friday morning studying the rest of the chapters because the final exam will be cumulative. And so that brings me to my next topic, which is the final exam. Of course, you guys know it is this Friday, May 6th, as in 4 days from right now. You will be in Canvas testing mode from 12:30 p.m. until 3:20 p.m. So this timeline is set by the registrar's office. I am going to stick to this timing window. The final exam is not, let me repeat that, the final exam is not going to be like our other 3 exams for this course where I gave you a broad window to be able to do it, because I would like to abide by the registrar's assigned time slot and make sure that it gets done during that time frame. So that's when it will be. It will open up on Canvas for you at 12:30 p.m. and you will have until 3:20 p.m. to complete it. You will need the Respondus lockdown browser. I'll talk about that in a minute. The final exam is cumulative. It is going to be roughly evenly distributed over the 10 chapters. We are going to have, it is all going to be in Canvas, and you can expect about 70 or 80 questions that are going to be multiple choice, mostly multiple choice. However, there will be some fill in the blank or true, false, or sort of that sort of thing. And there may be 1 or 2 short answers. I can promise you there won't be very many short answers because I would have to grade those by hand. But there may be 1 or 2. There will not be a written portion. I'll talk about that a little bit more over the next couple of slides. It is going to be closed book. So the final exam is going to be closed book, closed notes. You will not be able to use any resources except what you have contained in your brain as you've been studying. You will have to use the Respondus browser to be able to take the final exam. So all of this should be old hat for you guys. Everything that I've described so far is going to look very much like the part 1 of exams that you've had with me so far. All right, so there will not be a written portion, so there will not be any uploads. There will not be any free drawing of molecules. But keep in mind that there is a possibility for short answers. And so I may be asking you to use your words to describe or explain things in a short answer format. For example, which of these resonance structures is the most stable and why? So I might ask you which one is going to be the most stable. Explain your answer in 1 to 2 sentences, for example. And so you might have to do something like that in a short answer format, but everything is going to be self-contained within 1 Respondus Canvas exam. Okay. Regarding some questions in the chat, we've already covered there's not going to be a free draw portion, but there may be some short answers. And someone's asked, do you think it will take the full 3 hours? All right, well, so it's not quite 3 hours. It's 2 hours and 50 minutes. I do not expect it to take the full time. I do not expect it to take the full time, but that full time is available to you. So there's such a wide range of how long people take on exams. So I've been giving you guys 75 minutes to answer 25-ish questions so far. And most people are finishing that in under an hour. And so if you kind of extrapolate that, it should be it should be well within the 3 hour or the 2 hour and 50-minute time limit. Each question will be 100% divided by however many questions there are. My expectation is that all of the questions will be weighted evenly. So every question will be worth 1.5 or 2 points, it looks like. And you will have the ability to go back and review your answers if you have time at the end. But I do encourage everyone to review the technical difficulty section of the syllabus to understand that concept fully. That I've asked you guys when you're taking these Canvas tests to select an answer for every question moving forward, because if you get kicked out of the exam, the answers that you have in place will be the ones that are counted. And if you've skipped over questions, I will not be able to go back. So if you get kicked out of the exam and I'm reposting you an exam for technical difficulties, I'm going to post you from wherever you got to forward, and whatever's behind you is behind you, because that's the best way I could keep it fair for all of your classmates in terms of curtailing cheating and looking things up and stuff like that. So just review that concept on your syllabus for how we deal with technical difficulties. But yes, you can backtrack if you have time in the end to go review your answers. Okay. I think that's all I have to say about the final exam. So if you guys have other questions about the final exam, now is the time. My next announcement is just a reminder that course evaluations are open, and they will be open until the end of the day tomorrow. I do appreciate your feedback. I welcome your comments, both positive comments about things that you liked about my course so that I can make sure to keep those intact in the future. And also I do appreciate constructive professional feedback. I have incorporated aspects of this current course based on suggestions from students in the past. So I don't mind. I actually very much appreciate your suggestions and feedback on all sides. But I encourage you to fill that out because I do look at those and I do take them to heart. Okay, next set of announcements and reminders is just a kind of a reminder about things you guys should already know already about resources that you have available to you as you're studying. I know it's sort of a quick turnaround between our last day of classes and the final exam, but hopefully you guys have been studying some over the weekend and keeping up with material throughout the semester. But as a reminder, you don't have to do just your lecture notes and slides that are posted in the book. You also have other resources like me. And I'll be available to you guys during those additional office hours. And of course, between now and Friday, I will be paying attention to my email. So if questions come up, I can try to turn those around quickly as well. And like I mentioned earlier, I'm going to try to have a couple of additional pop-up office hours at different times. So just keep your eye out on Canvas for those announcements. I am just one person and there are a lot of you guys. And so keep in mind also your other resources like the Campus Learning Center. They have tutors that are available for drop-in tutoring hours that are specific to this course, that have been through this course, that are really good at their jobs. And they should be able to help you if you're struggling on a particular problem or if you want some help with a particular topic. They are really great at those sorts of things. You just need to be sure to go there with a targeted sort of bullet list of things that you want to cover with them, and they'll be able to help you out. The schedule is changing for the drop-in tutoring, so it's different during final exams than it is during the regular semester. So today and tomorrow, which are regular semester days, the Campus Learning Center has someone there to address Chem 301 specifically between 12 and 8 p.m. on both days. And then as of Wednesday and beyond, there will be a whole new schedule, which they haven't posted yet, but they'll be posting it at some point today. And you can click on either of these two links to find out more about the schedule. Also, the Campus Learning Center is hosting an event pretty much for the whole afternoon on Wednesday, which is reading day, so the day after tomorrow. And this event is called Ramp Up for the ACS. Get it, Rams? Okay. So this is targeted towards people who are giving the ACS exam as their final exam for Chem 301. However, I will tell you, our exam and my testing style is very similar to the ACS exam testing style for the multiple choice part. So this, don't get scared away thinking it won't be relevant to you. It is still really relevant to you guys because the questions that I ask have a very similar style. They have a very similar difficulty range as the ACS exam.
I have a question.
Oh yeah, go ahead.
We have to take the final and the ACS or just the final?
No, you guys will not have access to the ACS exam. You guys are only going to have access to a final exam that I have personally written that will be delivered via Canvas.
Thank you.
Yeah, you're welcome. So the ACS exams are on paper only. There's actually no way to give the ACS exam electronically because the ACS exams are not allowed to be reproduced or photocopied. It's illegal. It's actually a whole deal where it's illegal to reproduce them in any format. So you guys will not be taking the ACS exam, but this Campus Learning Center event is geared around the ACS exam. So here's the flyer or part of the flyer for the ACS exam. And I will email you guys the whole flyer so you guys have a copy of this, but this is the relevant portion to our class. You can see this is on reading day. This is Wednesday, May 4th. And you can see that there are 4 different topics is how they've broken down their kind of review sessions. Nomenclature and basics, stereochemistry and isomers, SN1, SN2, E1, E2. So chapters 6 and 7 here. And then chapters 8, 9, and 10 for the reactions of alkenes, alkynes, and making alcohols. They're not going to talk about the reactions of alcohols. They'll talk about making alcohols. So keep in mind, this is a really great event. These are good resources. This is in person in Hibbs Hall on Wednesday from 12 to 5, but comes with some caveats. Every single room is going to be limited to 30 students. And so the maximum capacity here, because there's going to be 2 concurrent sessions, 2 rooms happening at the same time. So the capacity here is only 60 students. Now there's 150 of you guys. There's 130 folks in my morning session for this class, and there's another session taught by another professor. So these sessions might very well fill up, and it is first come, first serve. So just pay attention to the rules here. They are posting sign-up sheets ahead of time, an hour and 10 minutes ahead of time, in fact. And so that is how they're kind of controlling access and also making sure that people who don't get into the first one can sign up for the second one, for example, and things like that. Okay, so that's going on Wednesday. Again, I have office hours on Tuesday. This ramp up for the ACS is going on Wednesday, and then I have office hours again on Thursday, and you guys have your final on Friday. So the last resource that I wanted to mention is each other. So this is perhaps one of the most overlooked ways to get good studying in is to get together with some classmates, either virtually or in real life, and actually try to teach each other. So this is something that I've learned over the course of my career, that absolutely, hands down, the best way to learn something is to have to teach it to somebody else, because it really draws out all of the nuances, and you have to really make sure that you understand it in your head to be able to communicate it out to somebody else. So my advice or suggestion is that you can try getting together with some classmates, pick a set of topics, and take turns trying to teach each other key points about those topics. You can even make up practice problems for each other to try. So this is actually what your SI leaders do for you guys, right? They make up problems kind of on the spot for you guys to try out. You guys can do that too. There's no reason that you can't. And this is a really good way actually to learn, is to have to think about it from the other side of things, from the teacher side of things. It'll make you really think about things deeply and in all of the details that you need to think about to be holistic in the topic. Okay, here's the last slide of announcements and reminders, and that has to do with grades. So I just want to put up some notes and reminders about grades. Of course, you still have a couple of outstanding assignments that are not due yet, that'll be due at the end of the day tomorrow. After that due date passes, I will take everything that I have and I will calculate all but final exam grades and post them in Canvas. So I'll go in and I'll figure out how the dropping of the quiz works and all of that kind of other stuff. And I will be clear and try to post those in Canvas. As of right now, right this moment, I believe that all of the quiz and test answers or answer keys should be posted or accessible, meaning if it was a quiz in Canvas, I think you guys can go in now and see all of your answers. If it was a free response section, I believe that all of the answer keys have been posted. If I am mistaken about that, then please send me an email because I cannot keep up with the chat box right now. Send me an email to check in, but first check on Canvas and make sure whether or not you can see whatever it is you're wondering about. I have not yet released your exam 3 part 2 grades. They were just finished up this morning and I will release them right after class. Exam 3 part 1 was posted over the weekend, so you guys should be able to see your grades for exam 3 part 1 and also the exam 3 part 1 answer key within Canvas. And the exam 3 part 2 answer key has been up since this weekend. But I haven't released your individual grades yet, but I will be doing that after class today. Okay. Just a reminder that there have been some extra credit opportunities throughout this course, and just like with Achieve, it is not too late to do those extra credit assignments. So if you did not do your chapter 8 chart, but you still want to and upload it in the spot where the chapter 8 goes, you can still do that. Likewise with all of the in-class participation assignments, if you missed some, you can still upload them for partial credit. Just a reminder also that the Earth Day webinar extra credit opportunity is still live and will remain live pretty much throughout the entire exam period. I think I set the due date as the 13th. So even after your final exam, you can go in and watch one of the free webinars and write something up about it. If you choose to do that, be sure you look on Canvas for the instructions of what I'm looking for the summary, because it is important to me. I'm using this not just to expose you guys to the broader world of chemistry that's out there, but also to help you make connections with something from this class and the broader world of chemistry. So those are key features that I'm going to be looking for when I look at those assignments. Okay. Likewise, it's not too late to boost your Achieve scores. There's a 10% flat penalty for any Achieve assignments that are late. And so that's still 10% between now and the end of the semester. So all the way up until the 13th, you can still do undone Achieve assignments. I would encourage you guys to try to do them before the final exam, just because it's helpful as review and practice. And hopefully you guys have been doing them all the way through the semester as well. Someone has added in the chat box, how are the extra credit points calculated in our grade? There's too many different little extra credit things and moments throughout the course. So what's going to happen is that once I'm done calculating these all but final exam grades and post them in Canvas, I'll post an announcement to let you guys know that they're there and available for you to look at. And when I post that announcement, I will also post someplace either in that announcement or in Canvas a very clear and detailed guide to how the grades were calculated, including where and how the extra credit came into play. So stay tuned for that. Okay. On that note, do not trust the Canvas grade calculator. Canvas makes us create a gradebook entry every time we create an assignment. And so if you guys wanted assignments posted so that it would show up in your calendars, I was doing that all semester, and it royally messed up the Canvas gradebook because now there's all sorts of things in the Canvas gradebook, and Canvas is not very good about letting me deselect or unselect what's included and how it's included. So whatever grade you see in Canvas, you need to take that with a grain of salt if it's a calculated grade. If it's a direct grade, like your quiz grade for quiz number 3 or your exam number 1 grade, you can trust those. All of the grades that are direct grades should reflect what those scores actually are. And if there's a few of you that I still need to go back in and make an adjustment for some grading error, so I promise I will get to those. But if you believe that your quiz or test grade reflected is not correct, you need to email me and reach out if you haven't already. If you have already, give me another couple of days of your patience. I think we'll get that all sorted out. But any grade that Canvas calculates for you, I just want you guys to be aware it may or may not be correct depending on the grade. Somebody's got their mic off. Do you have a question? No, okay. If you want to be able to project your grades ahead of time, and I haven't posted your projected grades yet, I put the equation here so you can do that yourself. You can take your participation average, multiply it by 0.1 because it's worth 10% of your grade. Your achieve scores, which are located only in achieve right now, and multiply it by 0.15, which is 15% of your grade. Quizzes times 0.2, tests times 0.3, and then you can estimate what you think you might get on the final exam. And you can play around with this number to see how it affects your overall grade. So I put that equation up for you. This is nothing new or special. It's just math based on the syllabus breakdown. Okay, any questions about grades? I think that was my last announcement about grades. Yeah, you guys, on the syllabus it says we're going to drop the lowest quiz grade, and yes indeed, I will drop your lowest quiz grade when I do the calculation. So I would recommend doing that so that you can have an accurate view of where you stand. Okay. All right, so that's it for announcements and reminders. I'm going to take, we don't have that much more time left together, but I'm going to give you a super brief overview of the topics that we've covered, not in any kind of detail, but just kind of a laundry list version. And I hope I will get through my study tips for you guys also in the time that we have left together. The final exam's worth 25% of your grade. And that was in reference to something in the chat box. Okay, so here's our semester overview. You guys, we know we've covered chapters 1 through 10, but what does that mean, right? Like what all was chapters 1 through 10? Chapter 1 seems so long ago, right? So what I did what I want to do here is remind you guys and refresh your memories about the overall organization and layout of the course. And for the most part, chapters 1 through 5 were focused on fundamental concepts. We really learned a lot of different tips and tools and tricks about how to think about different things, about the structures of molecules, about bonding in molecules, about all sorts of different foundational concepts that are going to become the basis then of the reactional chemistry that we do from after chapter 5 and onwards. So I made a list. I went through the book and my slides, and I made a list of the topics, the fundamental topics that you guys have learned in chapters 1 through 5. And it's going to seem a little overwhelming at first, but before I show it to you guys, I just want you guys to keep in mind that many of these topics are things that you guys have been doing so frequently that they are almost natural to you now. And so they're, you guys are very fast now. If I ask you the hybridization of a carbon atom, you guys can do that pretty quickly. And it's kind of second nature. Looking for implied hydrogens, you guys do that almost second nature now. So here's the laundry list of the fundamental concepts that you guys learned throughout chapters 1 through 5. Like I said, some of these are kind of second nature, like implied hydrogens, how many lone pairs are on a particular atom. Some of them involve a little bit more thought, like you might want to review RRS assignments and the Kahn-Ingold-Prelog prioritization rules. You may need to review Newman diagrams, but these are all concepts that are fundamental ideas that are going to be, foundational to the reactions that we covered in the rest of the chapters. And for the most part, these fundamental concepts were covered in chapters 1 through 5. There's a couple of exceptions. So we learned about the EZ designation for pi bonds in chapter 7-5. So we got a little bit outside of chapters 1 through 5 here, and also degrees of unsaturation or elements of unsaturation we also learned in chapter 7. But many of these concepts come up again and again. So carbocation stability, you didn't really know it at the time that you learned it, but think about how important that has become all the way through chapter 7, chapter 8, chapter 9, chapter 10. This is a critical piece. And likewise, being able to identify and see an allylic position and put that into perspective with other stabilities of carbocations and radical stability and things like that. Okay, so these are all of your fundamentals. I don't want you guys to be overwhelmed by this though, because if you go through one by one, I think you'll be able to say to yourself, what's my comfort level with that topic? And my hope is that this slide will really help you guide your studying so that you can quickly review things that you feel really comfortable with and spend more time on the things that you are feeling less positive about. Okay, so that's chapters 1 through 5. Chapters 6 through 10, and also a little bit of chapter 4, we were less focused on fundamentals and more focused on what we can do with our chemistry, right? What are the reactions that we've learned and that we know? And so I also made a laundry list for this. And I've kind of organized it by chapter, as you can see here. So the different chapters where different things appeared. And I did not go through a laundry list each type of reagent or each type of reaction, but I tried to give you groupings about when and where you learn things and how they relate to each other. So for example, chapter 6 was all about substitution reactions. Chapter 7 was about elimination reactions. But also at the end of chapter 7, which relates also to chapter 6, we also need to figure out, because all 4 of these reaction pathways are accessible to alkyl halides, we need to be able to differentiate when we can apply each of the different ones and what substrates are going to be likely with different pathways. I also wanted to point out here, for example, in chapter 8, we can think about the reactions in chapter 8 in terms of what is the reagent and what does it do. But we also need to think very hard about the stereochemical consequences of the mechanistic reaction involved. What is the regiochemistry? Is it Markovnikov or anti-Markovnikov? And is there a stereochemistry role that can be played by the reagents there? So you can see I tried to just pull out key features from each of our later chapters to focus on reactions. And really seriously, I want you guys to take a moment and be proud of yourselves and think about all the material that you've learned, all of the things that go into the laundry lists that I've had on the last 2 slides here. And just really, give yourselves a round of applause and a pat on the back, because you guys have been through a lot this semester. We've been through a lot together this semester, and we've covered a lot of material. And I very much hope that you guys are feeling good and well set up for next semester based on what you've learned here. So with that said, I don't have much time left, really any time left, but I do want to give you guys a couple of quick study tips. These will also be posted. I will post these slides with the study tips. So if you have to go, you're welcome to go. But basically, here's the quick version of how should I study. The most important and helpful thing you can do is look at where you've been, review your previous exams and quizzes, compare your answers to the answer key, look at wherever you went wrong, figure out, is that something that I didn't understand, or was it just a brain lapse in the moment, right? Take anything that you didn't understand and go get help. Make sure you understand it before the final exam so that you don't make the same mistake again on the final exam. Come to my office hours, go to the campus learning center, talk to your friends, whatever you need to do to find out the answers for why that didn't work the way you thought it would. Go ahead and reach out for that. The content list on the earlier slides, those last couple of slides, can help you find your personal hotspots for where you should focus your energies. There's suggested problem tables at the back of each chapter. I've talked about that a couple of times throughout this semester. There are in-class participation slides throughout many of the lectures in this course. So you can go get the blank ones and use them as practice tests and then check your answer against what's posted online. There's blank Achieve assignments that are available, extra ungraded Achieve assignments. And I'm also going to be reopening all of your quizzes and tests as blank versions so you guys can retake those ungraded, but for practice, so that you can be able to do that. And that's all of my advice to you guys. I'm going to post all of these slides that kind of go into that in detail, but I just want to get to the end so that I can say to you guys, there it was, Thank you all for a great semester. I really do appreciate you guys. I wish you the best moving forward. I hope to see some of you in Chem 302, which I'll be teaching next semester. And that's all I've got. I'll stick around for questions, but thank you guys for everything this semester. And don't forget to fill out your course evaluations.
Thank you.